All right, so I think this is recording. Let's take a look at these two inequalities. They're both compound inequalities, and they both have the word or, not an and. So in number 11, I like to, when I'm solving my inequalities, get the variable on the left-hand side and the constants on the right. So I'm going to start out subtracting 10x from each side. 1x minus 10x is a negative 9x is greater than or equal to, and I'm also going to subtract 5 from each side. You can see that when I do that, the 5's cancel. 5 minus 5 is 0. If I divide each side by a negative value, I'm going to have to change the direction of the inequality, and 0 divided by negative 9 is 0. So on the left here, my solution set is x less than or equal to 0. That will satisfy any values of x that are to the left of 0 or equal to 0 will make this a true statement if you substitute it in. Now, what about the other inequality here? We have or. We want values of x that satisfy this inequality. Let's subtract 2x from each side. That'll give me x greater than or equal to. Let's subtract 2 from each side, and 8 minus 2 is 6. And so I've got my solution set right here. Let's say that over here we have 0. And values of x that are less than or equal to 0. Well, we're going to include this 0 because it has an equal portion. And values of x that are less than 0 are to the left of 0. So here's a graph illustrating all the real numbers that are less than or equal to 0. Somewhere to the right of 1 down here is the number 6. And the endpoint 6 is going to be included because it's less than or equal to. It's because this equal to that I make this a solid dot, and the values of x that are greater than 6 are here to the right. So if you pick any number that's in the shaded region, either on the left here or on the right here, including the endpoints, and you plug it in to both of these equations, both of these inequalities will be satisfied. They'll be true statements. If you try to plug in values that are between 0 and 6, strictly between 0 and 6, neither one of these inequalities, well, you may have one of them being satisfied, but not the other. All right, so how do we express this in interval notation? Well, on the left here, the left arrow is shaded, so I have negative infinity all the way up to 0. I'm going to include 0, or from 6 to infinity. So values picked from the shaded region satisfy this compound inequality. Values that are in the unshaded region do not satisfy this compound inequality. All right, so let's take a look then at number 12, see if we can't figure it out. Again, it's a compound inequality, but it's the word or. So in our graph here, we're going to have both tails shaded in, or possibly, I guess, a special circumstance would be the entire real number shaded in. Let's take a look and see what we have here. I'm going to collect the x's on the left-hand side, so I'm going to subtract 7x from each side, and I'll have negative 10x is greater than, and I can see that if I subtract 10 from both sides, that those cancel. So I have negative 10x is strictly greater than 0. If I divide both sides by negative 10, then I have that x is strictly less than 0, because I had to change the direction of the inequality when I divided by 10. And 0 divided by 10 is 0. Now the other inequality, let's collect the x's on the left-hand side. Let's take 6x away from each side. That'll give me 2x is greater than or equal to. And let's add 10 to both sides. So the negative 10 will cancel. and 8 plus 10 is 18. If I take half of each of these, if I divide each of these by 2, then I have that x is greater than or equal to 9. So we have a situation that's very similar to over here on the left. We've got we're going to exclude, though, the endpoint 0, and to the left of 0 is shaded in. These are all the values of x that is less than 0. Or if you pick any value that is, I'm trying not to sneeze during the video so I don't sneeze right where you're listening to it. It's very difficult right now. This I'm going to include the endpoint 9, and I'm shading to the right of 9, so here's a picture of that. Now, to describe this using interval notation, when we have a break here, we have to use that union. That symbol U is the mathematical symbol for OR. So we have -1. No, I don't. I have the arrow shaded. Now that's something that if you're tired or not paying attention, just because -1 is the last number here that I've written on the net, the arrow is what's shaded in, so that's representing negative infinity. And then up to 0, and I'm excluding that endpoint. And then I've got OR, and over here I'm including this endpoint, so I need a bracket, and the other arrow is shaded, so that's going out to positive infinity. So here's my solution set written in an interval notation for this compound inequality. So I hope that helps, and I will talk to you later. Bye.